This is the video solution to practice problem A that goes with sample problem 3.2 on page 80 of your text. This problem requires us to determine the percent by mass of each element in acetaminophen. We're given the chemical formula for acetaminophen as C8H9NO2. Let's review how we'll carry out this calculation. Equation 3.1 on page 79 of the textbook shows us how to calculate the percent by mass of any element in a compound. We have to multiply the number of each type of atom by the mass of those atoms and then divide by the total mass of the compound, which is the molecular or formula mass. This quotient then is multiplied by 100% to convert it to a percentage. In our case, the denominator of this problem will be called molecular mass because acetaminophen is made up of only nonmetals. It's a molecular compound. The mass of each atom will be the average atomic mass that's reported on the periodic table. Our mass units will be recorded in AMUs. Finally, this should be a problem that's really easy to check because once we're finished, the sum of all the percents that we calculate should add to 100. If we begin by calculating the molecular mass, we'll be completing most of the work in this problem. The molecular mass is the sum of the masses of all of the atoms in the compound. We'll start with the carbon and multiply 8 carbon atoms by 12.01 AMU, the average atomic mass of carbon from the periodic table. Acetaminophen contains 9 hydrogen atoms, each with a mass of 1.008 AMU, so we'll add that in. We have 1 nitrogen atom at 14.01 AMU. And finally, 2 oxygen atoms, each with a mass of 16.00 AMUs. The sum of all these values is 151.162 AMU. In this value, the 6 is the last significant figure. We won't round this value yet, though, because we haven't finished the problem. Now we can work through the percent of each element. Starting with carbon, we'll use equation 3.1, and we can say that the mass of the carbon is 8 times 12.01 AMUs. We divide that by the molecular mass of the compound, the 151.162 that we just calculated, and then multiply by 100%. Notice that the units of AMU cancel, and this leaves us only with units of percent at the end of the problem. My calculator says that the solution to this is 63.5609479%. Since we only know the average mass of carbon to 4 significant figures, this percentage should be rounded to 4 significant figures. Therefore, we'll call this 63.56% carbon by mass. To calculate the percent hydrogen, we'll multiply 9 hydrogen atoms times the mass of hydrogen, which is 1.008 AMU. Divide that by the molecular mass that we calculated earlier, 151.162 AMU, and multiply by 100%. This calculation results in 6.0015083%. But again, we must round to 4 significant figures based on the mass of that hydrogen atom. We'll end up with 6.002% hydrogen in this compound. Our percent nitrogen by mass will be the mass of 1 nitrogen atom divided by 151.162 AMU times 100%. This calculation is 9.2682023%. This is also rounded to 4 significant figures, and we end up with 9.268% nitrogen in acetaminophen. Last but not least, the oxygen will be 2 times 16.00 AMUs divided by 151.162 AMUs times 100%. This calculation results in 21.1693415%. This is also rounded to 4 significant figures, and we have 21.17% oxygen in acetaminophen. Earlier we said that this problem should be easy to check, so let's do that right now. The sum of all our percentages should equal 100%, and when we go back and add all of the values together, that's exactly what we get. Please take some time right now and complete practice problem B in this group. You can check your answer with the key that's in the textbook on page 115. As you practice, make sure that you get in the habit of writing the correct units on every value that you record.